Good afternoon. The main theme of this year's event is Power of Python. And here I would like to show you how our data science workflow functions at Veriff and how we use the power and potential of Python in each step of it. So let's get the ball rolling. My name is Tosh. I'm a data scientist at Veriff, and before joining Veriff, I was making research on computer vision and machine learning. That's pretty much all I have to say about myself. I would now like to move on to Veriff. Veriff is a global tech company building a visionary AI-driven verification platform. No matter what your customers need, whether open a bank account, rent a scooter, or share a ride, we can help you to make sure your customers are who they say they are. I believe some of you might have already heard about us, so I would like to draw your attention to this quick recap of Veriff now. Veriff is now almost 5 years old. It was established in 2015, and shortly after, it popped up in Global Radar in 2018 by joining Y Combinator's winter batch. Having a funding of $23.8 million, we have now 235 people working in our offices in Estonia, the United States, and the United Kingdom. And now let me show you how our product works. To verify your identity, all you need is a government-issued ID and a device with a camera. Then you can start the flow by selecting the country issued your ID. Then you will see a list of ID documents supported in the selected country. You can choose one of them. In the next screen, you will be asked to take a photo of the selected ID document. In the example, an ID card was chosen. In the following step, to verify liveness and compare biometric data, you will be asked to take a selfie. And voila, the rest is on us. Veriff runs checks on the submitted photos and your ID is ready to be verified. Okay, I might have oversimplified what we do up to this point, because in the backstage, it takes much more than just making sure that two images match. It needs an intelligent decision engine. You can't just trust your eyes because humans are subjective by nature and make mistakes when handling huge amounts of data. To escape that, we are leveraging device and network information, customer behavioral analysis in a video-first approach. This enables our intelligent decision engine to give objective answers because we are using AI as the main driver of decisions. Let's take a look at our intelligent decision engine now. As any advanced decision engine, ours also consists of many components with various complexity. Our if-else blocks are made as simple as possible, but no simpler. As in decision science, our if-then-else rules can be mainly categorized into expert-based rules and data-based rules. Expert-based rules are obtained from our specialists using our knowledge about identity verification and thousands of supported documents around the world. They might be seen as subjective, but they should not be frowned upon as inferior. Because mind that, they are very popular in decision science, and especially in fraud detection. Data-based rules are obtained from data using analytical techniques like rule induction or decision trees. Second type of building blocks are traditional computer vision and machine learning algorithms. There is no denying that deep learning methods are superior over traditional computer vision and machine learning, but are they always the best solutions? When traditional computer vision and machine learning solutions solve our problem, we use plenty of them. And finally, our state-of-art deep learning models. They are powered by our massive data repositories, and we are leveraging both our in-house solutions customized for our needs and also external solutions provided by our partners. As you might guess, external solutions are cheaper and easier to use and maintain, but most of the time we need to develop our own models tailored to our needs. This is where our data science workflow takes the stage. I would like to illustrate the data science workflow here. First thing you should notice, this doesn't look like a traditional software engineering work cycle. This is because uncertainty is an intrinsic property of machine learning, and therefore subtasking can lead to unforeseeable downstream effects. We can split our data science workflow into 4 main steps, which can be a cycle within itself. The first step is defining the problem, followed by building the machine learning model, deploying the model into production, and measuring its impact in data production pipelines. Now, I would like to expand on each point and give you a peek of our everyday work at Veriff. Define. Each cycle begins with a business problem. With the help of product and data ops teams, we can translate the business problem into a machine learning problem, define the minimal viable product, and get the annotations. Because what else can define a problem better than the annotations itself? Talking to data scientists out there, now hold your seats tightly. At Veriff, we have massive repositories of data. We have more than 200,000 high-quality image annotations in around 50 distinct datasets. In addition to that, we have millions of weak image annotations, tens of thousands coming each day. And it all thanks to our data ops team consisting of 10 specialists focusing on compiling high-quality datasets. We optimize our data ops workflow with our in-house annotation tooling, powered by Python backend. In the example, you can see the UI of our annotation tool. The specialist enters upload IDs that she would like to annotate and chooses the annotation task. In the next step, we can see the upload and additional fields that need to be annotated. The correct label for this specimen is a unique internal ID. As you see, we also need to tick the glare checkbox here. After that, the annotation is stored in our database, waiting for review if needed. Okay, the second step is building the machine learning model. This step is a cycle itself and a standard when you develop any machine learning algorithm in the industry. So I would rather like to concentrate on how we do it at Veriff. We use various internal APIs for database lookups. We use Python in its step. In the example, you can see how we can look up to the upload we just annotated in the previous step. We have all the data to compile the datasets. For neural network training, we mainly use 2 deep learning frameworks, PyTorch and TensorFlow. Together, they make more than 2/3 of the state-of-art deep learning research. And now, the following step is production. To put into steps, we productionize our machine learnings to ensure best performance in terms of computation and accuracy. We have a dedicated team that builds a platform our machine learnings are deployed and make prediction. Each model lives in separate microservices and their outputs are orchestrated to make decisions. The last step has another highlight, measure. We use our internal tools to monitor the model predictions and analyze the insights. Our in-house testing system can create a specific review environment and produce results on how our model interacts with the other components of the decision engine, even before the model reaches the production. And don't forget, you're not done. Now it is time to start from the beginning for the next iteration in search of a better model. Before finishing my talk, I hope that you're a little clearer on how our Python-powered data science workflow functions at Veriff. If you like what you saw and would like to be a part of our team, we are looking for data scientists to join us. If you're interested, you can reach out to me with email or go to our website.
Thank you.
And now it's the time for questions.
Yes, we already have a few questions that I can start asking you. And for everyone else, I would just say that if you have any questions, please write them in the session Q&A. So
Mhm.
first of all, what's the level of liveness protection that the Veriff solution can provide? Level 1 being high resolution printout, and level 4 being 3D face map being used, and level 5 being a camera feed takeover.
Um, um, I'm not allowed to answer this question in very specific detail, but we can say that I can say that we are one of the best in preventing fraud or in industry.
Mhm. Okay. Another question is, what countries are supported by this solution? Is it able to successfully verify, for example, IDs from Nigeria or Ghana or African countries, for example, or in Asia?
Yes, yes, we can. For a detailed answer, you can check our website, but we support more than 190 countries around the world. And to the best of my knowledge, Ghana and Nigeria includes them. We support multiple documents from these countries
Mhm.
and also able to automate that.
Okay. I do not have any questions in the session Q&A, but we still have some time. So if someone wants to ask any question, just you can write in the session Q&A quickly, and we can take from there. Just I'll refresh and see if
Mhm.
there's any questions. Okay, so nothing at the moment, but feel free to write to Dogush also in the app, or to write on the email address. Please do go check out the careers page of Veriff, see the open positions that they have. And well, we can take one more question that just came in, and that is,
Yeah.
what is the seniority required for the data scientist position?
We are now hiring both senior and junior levels.
Okay, perfect. Okay, thank you so much. Thank you
Mhm.
for giving time and being here at PyCon and for the talk.
Mhm.
Uh, for everyone else, I would just say that please send your questions in. You can send them in via email. Just write to Dogush. And there's also some other people from the Veriff team. You can find them in the attendee list and just write to hopefully any one of them, and they would be able to help you. But thank you so much. And we will go to our next session, which is just let me uh, quickly check. Yes, so we have our next talk at 2:30, so in around less than 20 minutes. And yeah, see you in the next session then. Bye.